All right, so you're interested in Arduino, huh? Well, buckle up because we're going deep into the world of microcontrollers and Arduino with this stack of university lecture notes.
It's going to be a fun one.
Definitely. Okay, so the notes start off talking about microcomputers, and I was surprised to learn they weren't always the powerful devices they are today.
Right. Yeah, they used to be much simpler, just basic calculations and stuff.
Wow, so how did they evolve into the machines we know today?
Well, over time, they just became more capable handling more complex math, even like floating point operations and all that.
Huh. The notes mentioned something about microcomputers with like a keyboard and screen basically being personal computers.
Yeah, pretty much. It shows how far they've come. But for this deep dive, we're focusing on microcontrollers.
Microcontrollers. So what's the difference?
They're kind of like the specialized cousins of microcomputers,
Right.
designed for one specific job within a larger system.
So like the behind-the-scenes workers of our electronics?
Exactly. Like your microwave, your remote control, all that stuff probably has microcontrollers running things.
That's pretty cool. So the notes describe microcontrollers as low cost, low performance. Isn't that a bit underwhelming?
It might sound like it, but it's actually a huge advantage. Not everything needs to be super fast.
True. I guess a microwave doesn't need to be solving complex equations. It just needs to heat up my food.
Right. And that's where microcontrollers shine. They're simple, reliable, and cheap. Perfect for tasks where speed isn't the main concern.
Got it.
Yeah.
Now the notes also compare Raspberry Pi and Arduino. They both sound pretty cool.
They are.
What's the difference?
Think of Raspberry Pi as a mini computer. You can run a full operating system on it, multitask and everything. Arduino is more focused on hands-on electronics projects.
Oh, so if I want to build a robot, Arduino would be the way to go.
You got it. Arduino is perfect for controlling LEDs, reading sensor data, and building robots. It's really popular for student projects because it's so versatile.
Okay, that makes sense. So what exactly is Arduino?
It's a platform that makes electronics super accessible even for beginners. It combines hardware and software in a way that's easy to understand and use.
The notes say Arduino boards are like chefs taking inputs and turning them into outputs.
Uh-huh. I like that analogy. Like, imagine you have a sensor that measures temperature. That's your input. The Arduino board takes that input and, depending on your code, decides what to do with it.
So it could like turn on a fan if the temperature gets too high?
Exactly. Or it could display the temperature on a screen. It's all about turning inputs into outputs.
Sounds kind of magical. But I'm guessing there's some circuitry involved, right?
Absolutely. Arduino projects come to life on these things called development boards. They're basically pre-built circuits that make it easy to work with the Arduino microcontroller.
So like a starter kit for electronics.
Exactly. And these boards have a ton of components, power circuit programming interface, LEDs, buttons, you name it. There are also different types of Arduino boards.
Wait, why so many different boards?
Because not all projects are the same. You can choose the board that best fits your project based on its size, processing power, signal types, all that.
Makes sense. The notes actually have a diagram of the Arduino Uno, one of the most popular boards. It shows a power connector, a USB port, a reset button, LEDs, even something called TXRX LEDs. It looks a little intimidating, honestly.
Don't worry, it's simpler than it seems. The power connector is for well power. The USB port lets you connect to your computer to upload your code.
Ah, so that's where the programming comes in. But what about those blinking lights? What are those for?
Those are like communication indicators. They let you know the board is talking to your computer, like when you're uploading code or sending and receiving data.
Interesting. So we have the board, we have the components, but how do we actually tell the Arduino what to DO?
That's where the Arduino IDE comes in short for Integrated Development Environment.
Sounds complicated.
It's not that bad. It's basically a software application that lets you write, upload, and manage your Arduino code. And it's free.
Oh, free is always good.
Yeah.
But the notes mention that Arduino code files have no visible extension. What does that even mean?
It's a bit unusual, but the IDE can handle different file types, even without those file extensions you usually see, like standard CC++ files, header files, and Arduino code files.
So it's like a code translator.
You could say that. It's designed to make working with Arduino code as easy as possible.
Okay, so we write the code in the IDE, but how does it actually get onto the board?
You connect your Arduino board to your computer using a USB cable. Then you got to make sure the IDE is set up correctly with the right board type and serial port.
And then we upload the code.
Exactly. Once you've written your code and checked for any errors, you hit the upload button and the code is transferred to the Arduino board. And you'll see those TXRX LEDs blink, letting you know it's working.
That's so cool. The notes call out two key functions in the code, setup and loop. What are those all about?
They're the backbone of every Arduino program setup. Runs only once at the beginning, and it's where you set things up like pin modes and variables. Then loop takes over and runs continuously as long as the Arduino is powered on.
So it's like setting the stage with setup and then letting the action unfold in loop.
Perfect analogy. Like, imagine you're writing a program to make an LED blink. In setup, you'd tell the Arduino which pin the LED is connected to and set it as an output. Then in loop, you'd write the instructions to turn the LED on, wait a bit, turn it off, wait and repeat.
Okay, that makes sense. The notes also have some code snippets, things like pin mode and digital write. Can you explain those?
Sure, pin mode is basically how you tell the Arduino how you want to use each pin on the board. Like, will it be reading a sensor, controlling an LED, or what? And then digital write is how you control the output of a digital pin. You can set it to high GH, which means on, or low, which means off.
So we're giving specific instructions for each pin.
Exactly. You're telling, hey, this pin is going to control an LED, so get ready to send signals to turn it on and off.
This is starting to click. But I do have one question. The notes mention analog versus digital signals. What's the difference again?
Remember the dimmer switch and light switch analogy? Analog signals are like dimmer switches. They can have a continuous range of values. Digital signals are like light switches. It's either on or off.
Right. So how does Arduino handle both types of signals?
It uses something called an analog to digital converter, or ADC. It basically translates those continuous analog signals into digital ones that the Arduino can understand. The Arduino Uno, for example, has a 10-bit ADC.
Wait, the Arduino Uno has a 10-bit ADC. What does that mean?
It means it can distinguish between N24 different levels of an analog signal.
Okay, I get it. So to recap, we build the circuit on the Arduino board, write the code in the IDE, upload it to the board, and then we debug.
Yep. Debugging is all about finding and fixing errors in your code. It's a normal part of programming.
So it's like being a code detective trying to figure out why things aren't working as expected.
Haha, exactly. And the Arduino IDE has some tools to help you out, like the serial monitor, which lets you print values from your code to your computer screen so you can see what's happening.
It's like seeing inside the Arduino's brain.
Exactly. The serial monitor is super helpful for monitoring variables, checking sensor readings, and making sure your code is doing what it's supposed to.
Awesome. The notes also mentioned using Tinkercad for virtual projects. Is that just for beginners?
Not at all. Tinkercad is great for anyone. It's a free online platform where you can simulate Arduino projects virtually.
Oh, so I can design a circuit and write code without even needing a physical Arduino board.
Yep. It's perfect for experimenting, testing ideas, and collaborating with others. It's especially useful if you don't have access to hardware or you want to try things out quickly without worrying about breaking anything.
That's really cool. And the notes mentioned that Tinkercad might be the platform for something called PBL2.
PBL probably stands for problem-based learning. It sounds like a hands-on project where you get to use your Arduino skills to solve a real-world problem.
I love that idea. It's one thing to learn the theory, but actually building something and seeing it work is a whole other level.
Absolutely. That's where the real magic of Arduino is, being able to take your ideas and make them real.
I can't wait. We've covered so much already, and I feel like we're just scratching the surface of what's possible with Arduino.
We've only just begun. There's so much more to explore.
Exactly. Make sure to join us for part 2, where we'll dive deeper into different Arduino board signals and maybe even unravel the mystery of PBL2. Welcome back to our Arduino deep dive. Last time we covered the basics of Arduino, what it is, all the components on a development board, and how to get started with the IDE.
Right.
So now let's look at some practical examples. The notes mention this thing called Take Home Activity 2ZK23A, where you fill out a table about different Arduino boards.
Yeah.
It seems like a good way to compare all the different boards and see how they stack up against each other.
Definitely. It shows you all the important specs, like the processor, the operating voltage, how fast the CPU is, how many analog and digital I/O pins it has.
Right, all that stuff.
You'll even see things like the EEPROM SRAM and flash memory sizes, which basically tell you how much data the board can store.
So many boards, so many specs. I'm already feeling a little lost. How do I even know where to start?
It can be a little overwhelming, but it all comes down to what you need for your project. The notes say you should consider the physical size of your project, how much processing power you need, the number of inputs and outputs, and what kind of signals you'll be working with.
But if I wanted to build a simple LED display, I wouldn't need a super powerful board with tons of memory.
Probably not.
Yeah.
For something like that, a basic board like the Arduino Uno would be perfect.
Yeah.
It has enough I/O pins to control a bunch of LEDs, and its processing power is plenty for basic animations or patterns.
Makes sense.
Yeah.
But what if I wanted to build something more complex, like a robot that could navigate a maze?
Now you're talking. For something like that, you'd probably need a board with more processing power, more memory, and maybe even some special motor control features. The Arduino Mega, for example, has way more I/O pins and a faster processor.
So it all depends on the project.
Exactly, the right tool for the job.
Speaking of tools, the notes also talk about understanding the types of signals, PWM, analog, and digital. Can we go over those again?
Of course. Remember the dimmer switch and light switch analogy?
Yeah.
PWM, or pulse width modulation, is like a digital way to get analog-like behavior. It rapidly switches a digital signal on and off to control the average power going to a component, like an LED or a motor.
So it's like a digital dimmer switch.
Exactly. It's super useful for things like controlling LED brightness or adjusting motor speed. The Arduino Uno has several PWM-capable pins, so it's a good choice for projects that need that kind of control.
Okay, that makes sense. What about analog and digital signals? We talked about them briefly before, but a refresher would be helpful.
Sure, analog signals are like continuous waves, kind of like sound waves from a microphone. Digital signals are more like discrete steps, like the zeros and ones in computers. Arduino boards have both analog and digital input-output pins, so you can work with all sorts of sensors and actuators.
So if I had a temperature sensor that sent out an analog signal, I could connect it to an analog input pin on the Arduino.
Yep. And the Arduino would use its analog to digital converter to change that continuous analog signal into a digital one that it can understand. And if you wanted to control a motor that needs digital signals, you'd connect it to a digital output pin and use code to turn it on or off.
It's cool how the Arduino can handle both types of signals.
It's pretty versatile.
Speaking of versatile, these notes keep mentioning PBL2. What do you think that is?
I'm not totally sure, but I bet PBL stands for problem-based learning.
Oh, so maybe it's a project where we get to use all this Arduino knowledge to solve a real-world problem.
That would be awesome.
Right. It's one thing to learn about Arduino in theory, but it's way more fun to actually build something and see your ideas come to life.
I totally agree, and who knows, maybe we'll come up with some really innovative solutions.
I hope so. Well, I think we've covered a lot in this part of our deep dive. We've talked about different Arduino boards, PWM analog, and digital signals, and we're even more curious about PBL2.
Yeah,
But we're not done yet, are we?
not even close. There's still so much more to learn.
That's right. Join us for part 3, where we'll go beyond the basics, talk about some debugging tips, and maybe even look at some real-world Arduino projects to get those creative juices flowing. All right, welcome back to our final Arduino deep dive. We've covered the basics, compare boards, and now it's time to get into some of the more advanced stuff.
Yeah, let's do it.
The lecture notes don't talk too much about debugging, but they do mention it's super important. So what are some common mistakes we could watch out for?
Well, even experienced programmers make typos, sometimes a missing semicolon or the wrong capitalization, and that can cause a lot of problems.
Oh yeah, typos, those can be tricky. What about when the circuit is built right, but the Arduino just isn't working the way it's supposed to?
That's usually a logic error in your code. Like maybe your if statements aren't quite right or your loop isn't running like you thought it would. Sometimes it helps to break your code down into smaller pieces and test each part one by one.
So like being a detective trying to find the bug in the code.
Exactly. And the Arduino IDE has some cool tools to help us out, like the serial monitor.
Oh yeah, the serial monitor, what's that all about?
It lets you print values from your code to your computer screen, so you can actually see what's happening at each step.
Oh wow, so it's like looking inside the Arduino's brain.
Pretty much. The serial monitor is really useful for checking variables, sensor readings, and making sure your code is doing what you want it to do.
Cool. Any other debugging tips you can share?
Don't be afraid to ask for help. The Arduino community is really big, and everyone is super helpful. There are tons of online forums and resources where you can find answers to your questions or get feedback on your code.
True. Okay, so the notes briefly mention libraries.
Right.
What are those all about?
Libraries are like pre-written code modules that give your Arduino projects extra functionality. Like if you want to control an LCD screen instead of writing all that code yourself, you can just use a library that someone else already made.
So it's like a toolbox full of ready-made Arduino code.
Exactly. Libraries can save you so much time and effort. Plus, the code in them is usually really well written and optimized.
That's amazing. So with all this cool stuff, what are some real-world examples of what Arduino can do?
Well, Arduino is really popular for home automation. Like you could control your lights, your thermostat, even your coffee maker from your phone.
Whoa, that would be so cool. What else can you do with Arduino?
People use it for all sorts of things, like robotics. You can build anything from a simple line-following robot to a super complex autonomous vehicle. And it's not just for hobbyists either. Researchers and engineers use Arduino all the time to prototype and test new ideas.
That's awesome. So the notes mentioned Tinkercad for simulating projects. Is that just for beginners or can pros use it too?
Tinkercad is great for everyone. Beginners can use it to get started, and experienced users can use it to simulate more complex systems, test code logic, and even work on projects with other people. It's especially helpful if you don't have the actual hardware or you want to experiment without breaking anything.
I love that. It's amazing how Arduino has made electronics so much more accessible to everyone. It's like this whole community of makers sharing ideas and making incredible things.
I know it's really inspiring. And the possibilities are endless. Who knows what awesome things people will create with Arduino in the future?
Well, that wraps up our Arduino deep dive. I hope you learned a lot and feel inspired to start your own Arduino adventures.
Yeah, have fun, experiment, and keep learning.
And who knows, maybe one day we'll be doing a deep dive on your amazing creations. Thanks for joining us.